Hello and welcome to this presentation. My name is Ryan Kane, and I'm going to be presenting my dissertation, or at least part of my dissertation study. This presentation is titled The Early Childhood Thermometer, Batteries Included, a dissertation examining kindergartners' perceptions of air temperature with a pedagogical aid. So my story begins in 2009. You can see me here pictured on the roof of the school that I used to teach at. That school was named PS3, the Bedford Village School. And you can see I'm pretty happy. I have a smile on my face because I'm standing next to a brand new weather station. And I thought that getting this fancy weather station would be the missing link that would make temperature measurement more meaningful to my students. At the time, that was mainly kindergartners and first graders. And something that I noticed, so the reason that I had the school purchase this weather station and some other interventions that I tried to better teach temperature was that I noticed that children were struggling to make sense of longitudinal temperature data. That is, that they weren't able to notice the change in temperature over the seasons to detect that pattern. In addition to my own personal interest in this, it's also the work is also motivated by the fact that national and state standards do call for kindergartners to be studying weather and making observations of temperature and looking for patterns over time. And you can see in the SEED standard that we really want to emphasize the students' collection and sharing of data. Another point motivating me to do this is that we're at a sad point in science instruction in schools, in elementary schools, that science instructional time is in decline, especially in the early elementary grades. So we might not be getting to teach science every day, but there's a nice connection with math. So in with the Math Common Core standard, students should be working in kindergarten to count to 100s by ones and tens. So I saw this as a nice overlap to connect science with math. And this was especially motivated by a math curriculum called Everyday Math, where part of their morning meeting, they do have children charting temperature. Now, something I want to point out, children are coming to our classrooms. They are not blank slates, but they bring pre-existing conceptions of science to school. And that's something that, as science teachers, we need to leverage. We need to include their ways of knowing the world around them because they have a lot to offer. And it can make for more meaningful science. And previous research has shown that documenting and engaging with prior conceptions is important to supporting the development of more normative conceptions. So if we want them to know science better, we should know what they're starting with. And previous research has also shown that interviews are a good method for eliciting these prior conceptions. So I'll be talking a little bit about how I interviewed the children in the study. Before we get to the nuts and bolts of the study, I just want to point out that there is a paucity of research in terms of looking at science, looking at temperature conceptions at the elementary level, especially at the early elementary level. I don't know if you can see this in the video, but only one of the studies that I identified was looking at early elementary. And early elementary, as I define, is grades K through 2. Now, this is a particularly influential study, Erickson 1979. It's a widely cited article in regards to conceptions of temperature, of what people, not just children, but adults too, how they think about heat and temperature. So we need more research looking at our younger students. You can see most of the research looks at secondary. Okay, so in terms of how people think about temperature and heat, there's a what I've referred to as hot and cold bodies. Um, and Albert, 1978, points out about hot bodies, but it winds up being sort of this binary where it's, something that's always known as hot or something that's always known as cold. So this could be fire and ice. Um, another naive conception of temperature would be hot and cold as separate substances. So, and you can hear this in our language when we talk about things like "don't let the heat get out" or "the cold got into my bones." And in addition to not having a good understanding of how temperature and heat work, um, we also know that young children have difficulty reading expansion thermometers. And naive conceptions can be improved by resolving the difference between perceived temperature and measured temperature by using computer-based temperature models. And this basically comes down to, people sometimes may typically associate metals as always being cold. And the difference is that metals aren't always cold. Any object, no matter what the material, according to the second law of thermodynamics, will reach equilibrium with the space that it's in. So if I have a block of iron and I place it in a cold room, it will eventually be the same temperature as the cold room. However, if I'm in the cold room, my body might confuse things a little bit because my body is thermoregulated to stay at 98.6 degrees Fahrenheit at all times. And then if I touch something that's cooler than it, that conducts heat, can conduct thermal energy very well, which is a metal. If I touch a metal, it's always going to feel colder than, say, if I had two substances in that cold room. Let's say I had a block of iron and I also had a block of wood. My body would think the wood is warmer just because it's not as good of a conductor of thermal energy. So the metal is able to transfer some of the heat out of my body faster than the wood. Okay, looking at the pedagogical aid that I've created for my study, as I pointed out on the left, children have a hard time reading these expansion thermometers. And this is, you can see that this is a classroom thermometer. So this is not meant for adults. It's meant to be used in schools, but it can be kind of confusing. And so you'll notice that it's visually complex with the tick marks between each of the numbers, the dual temperature scales. So in a kindergarten class, they're just learning their numbers, as we pointed out with the math standard, numbers 1 through 100. So to expect them to be able to know what those marks in between, let's say 60 and 80 are, that's a big ask. And as I'm pointing out, they, at this level, they have limited numeracy skills, and also the display is static, and you have to position the glass thermometer in such a way so that you can see that line carefully. So it might not be as noticeable to a young student. In terms of what I've developed, the pedagogical aid is the early childhood thermometer shown on the right. And these boxes are illuminated, discrete boxes with a simple temperature scale. So here we are skip counting by tens. They light up when you press this button right here. And it's a little more interactive. So something happens when you push the button, and it's pretty noticeable when it's working. And something that you might have noticed on the first slide was that the color scale changes as we go up. So it goes from blue, currently it's showing cyan, these two would then be green, and it colors the whole scale. Go to green, yellow, red, and then magenta for the highest numbers. Just a little background on the students. So I conducted these interviews with 6 children, all in kindergarten, and they represent a range of oral vocabulary listening skills. So that's being able to identify pictures and vocabulary. So that was an assessment that I gave just to kind of get a sense of where they were. Since I was interviewing them, I wanted to see what their vocabulary skills were like. And then I also gave them a numeracy test where it was just a list of numbers that they had to read. And you can see that there was a range. One of the students was able to read all the numbers, and then on the other end, one student was able to not read any of them. All the children were they were pretty close to 6 years of age. I'm going to skip this first research question just because this one can be its own presentation in and of itself. So I do plan on recording another video. But in this video, I'm just going to kind of focus on some of these lower level observations of how do kindergartners interpret the early childhood thermometer and commercial thermometers, and how do kindergartners interpret graphic representations of air temperature. A little more on the interviews. So you can see right here, I'm interviewing Catherine. She has a variety of thermometers in front of her, and she's reading those thermometers. And then, so part of the location was that we were inside the school, and then other times we were during interview 3. We went outside to compare different locations, and you'll notice here on the left side that the thermometer is in the sunlight right there, and then we have a second thermometer in the shade, and the children were making comparisons of those temperature measurements, and then trying to make sense of what was going on with the temperature difference if they measured one. Not going to spend too much time on my data and analysis process, but this involved 160 pages of transcribed interviews that I iteratively analyzed through a qualitative coding method. So getting into the findings. For research question 2, how did the kindergartners interpret the early childhood thermometer and commercial thermometers? Something that it was kind of interesting, and I was a little surprised, although you'll notice that 6 out of 6 of the children were able to make acceptable readings of the early childhood thermometer, and then 5 out of 6 were able to make acceptable readings out of the expansion thermometer. And here you can, in this picture, I've included this to kind of highlight the difference in the displays. So this one, that line is fairly thin. It does have the 2 scales. Now I will say that an acceptable response on the expansion thermometer, if they read this as 10, that would be acceptable. Some of them might have even read this as 40 or 60. So this was particularly confusing. But I still said, as long as they said a number that they felt that was closest to it. And then also being acceptable might be that if they misread the number. So maybe if they said this was 6, I would still take that, or 1. None of them said 1, but sometimes they would misread these numbers over 20. Now, in contrast, though, one thing that was positive about the early childhood thermometer was that they did prefer it. So I had them measure temperature using both of them, and then they were able to give me some reasons, some justifications on why they chose the one they chose. I did forget to ask the question to one of the students, but all the students that I asked, they did prefer it. So Erica said because it has lights and it's really cool. Erica, because I like all the boxes and touches many of the boxes, and it will tell us the temperature. And I made sure to include that touches many of the boxes, as this was a common way that the children were interacting with the thermometer. They would physically touch the boxes to count them, and I think that was a positive thing because in early elementary classrooms, oftentimes in math, when we're doing counting, they are using manipulatives to touch. So I think that was a positive feature, and you can notice that there is a little bump here, that the plywood of the face of the thermometer. So there is a physical separation between each of the segments in the thermometer. And then Malcolm, who was the student who wasn't able to recognize any of the numbers originally, and he was unable to read the expansion thermometer, he was able to read the early childhood thermometer, and he liked how it changes colors, and also made sure to touch that. Um, Now, a second part of the interview that I did in interview 3 is I asked the children to look at some, uh, on the right side, some commonly seen um, temperature plots, and then I also made a temperature plot that was similar to what the early childhood thermometer was showing. And as we can see, that the experience of measuring with the early childhood thermometer, that 4 out of 6 of the children were able to interpret this as the temperature was going up and going down. I told them that this was a day. The weather map over here in the middle, this one, about half the children were able to interpret, and they interpreted it based on color. So typically, we would expect, or, or, or we might expect that red could be associated with fire and yellow. So typically, students were saying that this was hot, hot, and then blue, they might say it was cold. There were a few students that then worked a little more carefully to decipher this key up at the top, and that was pretty interesting, where one of the students kind of broke it up into 2 parts. So these were cold, 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 hot, 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 and skipped it. Something that was really interesting, one of the students reasoned through that there was a colder part, a hotter part, and then he came up that this middle part, the green, was fine. So I thought that was pretty interesting, that he reasoned through that. And then this last plot, this one was the least interpretable. However, this came right at the end of a very busy interview, so I might not have included enough time for kids to really figure this one out. And this, I probably would say, would be the most similar to what I used to have in my classroom. So we would like to get to the point where a kindergartner could make sense of a line plot. Something that, since I didn't talk about my first research question, this part I'm just going to briefly cover. But here I started to try to place the students on a continuum of competency with temperature and the concept of temperature. And if we were to get over here, this might be the correct scientific conception. And it appeared that the students kind of had a range. So at the most basic level, just thinking of temperature as sort of a binary, either it's hot or cold things. As that progressed, some students showed that you could be more hot or less hot, less cold, more cold. But these were kind of separate and not so related. And then half of the students, though, showed this inverse relationship where they're getting towards one's common scale. So here, if we can think about this, this would be one temperature scale, and this one, these are opposites, but they're still separate. Contribution, implications, and limitations for the work. So for research question 1, which I didn't really talk about, children express temperature as symbols, colors, and effects on the human body. Research question 2, the early childhood thermometer was more interpretable than the expansion thermometer and more preferred, I should highlight. Research question 3, children could interpret the early childhood thermometer, inspired bar graph, and weather map, but not the line plot. Overall, the children exhibited temperature conceptions beyond what previous research has shown. So we can see in this study that kindergartners are pretty capable of making sense of temperature data, and we should work to engage what they know and provide them with tools. And those tools might be something like the early childhood thermometer, but then also the bar graph that I showed. So providing them with methods for recording temperature and talking about that temperature. So we should be making quantitative measures of temperature starting in kindergarten with proper support such as the ECT. And this exploratory study was based on 6 children from a single class, and inferences privileged more expressive children. So that just basically means that it would be in our best interest, to do future research that looks at children in more broad context, and that also figures out a way to engage children that might not be as chatty. One of the children that I placed at that beginning of the progression, Jonathan over here, um, he probably had a pretty good understanding, but he wasn't as expressive as the other students. So in the future, it would be good to have ways to get to better elicit voices like that in interviews. And here's where the journey ends. So the first picture I showed you of me in this blue jacket was in 2009. And then here I am in the fall of 2019. So 10 years later, and I have I'm holding the thermometer, and probably more importantly is the finished dissertation is in my hand. And this was probably the hardest thing I ever did in my entire life. And I only was able to do this through the incredible support of both the faculty up at Utah State, and then my incredible family. So thank you for watching this video. I hope you found it interesting.